and then click on dependencies. If there's any dependencies, it will show the dependencies. So let me just click on the dashboard. So if you can access all these and move things around, your installation has been successful and verified. So that's it for this lecture. Thanks for watching and bye for now. Hello and welcome. In this lecture, I am going to do my best to guide you as to how you can install PostgreSQL on a Mac. I haven't got a Mac to show you, but I will do my best to guide you as to how you can do this. The installation should be slightly different just because of the format. However, you'll be using the same graphical user tool that I used to show you the installation on a Windows-based computer. So we're going to start by going to the website. So the website is https://www.postgresql.org. So we're going to head over there to download the file. So this is the home page for the PostgreSQL. So if you click on this download tab here, you will have different options. So if you are on a Mac, you need to click on the Mac OS, click on that option. And then what you need to download the installer. You see this option here that says download the installer. This is what you need. So click on that and that will take you to the installer page. So where you've got select your version, you select the version of your Mac. For example, if the version of the PostgreSQL, so select the latest version, which is usually at the top. So select that one, and then for your operating system, click on the drop down arrow and select, there's only one option for Mac, just select Mac OS X, and then there's an option to download. So you can click on the download and that should download to your Mac folder or download that. I've just clicked on the download even though I'm not on a Mac, and this is the file. So it packages it as a DMG file, which is a disk image file. So to extract the installer, you basically simply have to mount the disk image and copy the installer to the desired location, or you can run it directly from the disk image. Please note that by default, Mac OS X ships with shared memory settings that might be too low for running the PostgreSQL. However, the installer will detect this and, if possible, reconfigure the shared memory and then may prompt you to reboot the system and rerun the installation. So if you get that happen, don't be surprised. So that's basically it. So just run this DMG file and just follow the screen instructions. So that's it. Thanks for watching. Any issues, please let me know. Bye for now. Hello and welcome. In this lecture, I will show you different ways to connect to a PostgreSQL database. You can connect using an interactive terminal program, which is also the shell, the SQL shell, or also known as PSQL. Or you can use the graphical tool, which is known as pgadmin. So that is a graphical admin tool. So those are the two ways you can connect to a PostgreSQL database. So both the SQL shell, which houses the PSQL, and the pgadmin GUI are installed when the Postgres database is installed. So let's go over to our program menu and explore both options of connecting to the data. To launch PSQL, you click on the Start menu, go to All Programs, click on the PostgreSQL 9.6 folder, click to expand, and this is the SQL shell which houses the PSQL. So click to launch, and when you open it, this is what you get. If you press enter, it will also add the database name. This shows you that the server is localhost, so it's a local installation. So press enter, it will give you the database. So it tells you the database name is Postgres. That's the default database that comes pre-installed when PostgreSQL is installed. If you press enter again, it will give you the port number, which is 5432. And if you press enter, it will give you the username that is used to connect to the database. So this is the username called Postgres. If you press enter, it will prompt you for a password. The password it's asking for is the password you would have set during the installation of the database. So just type that password in. So I'm just going to type mine and press enter. If it is right, it will connect to the database, and you get this warning here with some instructions here saying blah blah blah. But if you can see this flashing cursor, it means that you have successfully connected to the database, and this means the database is just waiting for some instructions. So as it is, you can execute a SQL query. Once you've got that flashing cursor there. So that's how you connect to the database using the SQL shell or the PSQL. So I'm just going to exit out of that. The second option is to use the pgadmin tool. This is also located in the same directory as the SQL shell. So click on Start or Programs, go to Postgres, click on that, and this is what we want, pgadmin 4. That's the current version. If you click on that, it will launch the pgadmin tool, and the latest version of that tool is version 4. Please be patient with this tool. It can sometimes take a while to open up. Once the tool opens up, we can connect to the database by expanding the servers here where it's got servers. Click on the plus sign to expand, and you've got the PostgreSQL 9.6. So click on that. It will give you an option to enter your password. So I'm just going to click expand that. There you go. So this should pop up. It says connect to server, and the username it's using to connect is Postgres. So you need to type in the password you set during the installation. So I'm just going to pop my password in there and click OK. And if everything checks out, you can see here it says server connected. Once you're connected, it tells you you are connected, and we can now access the database. So these are at the moment we've only got one database. That's why it's got one there, which is the default database installed with the PostgreSQL database, which is this one here. That's our default database. So basically those are the two main ways you can connect to a PostgreSQL database. Another way to actually interrogate or interact with the database is via the query. So if we click on the tools here and go to select the database first, make sure you got the database selected, and then click on tools and click on the query tool, and that should bring up the query editor. So just write a simple query that will interact with the database. So you just type in select followed by the version. You're looking for the version, and then parentheses and a semicolon. And then you click on this arrow there to execute the query, and it will show the result in the output here. So this is the output for the query. It tells you the version is PostgreSQL 9.6 and give you some information about the build and so on. So this tells you, you can expand this. By the way, you can see I've just dragged it to expand it along to reveal more information. So it gives you the version and tells you it's compiled by Visual C++ and the rest of it. So that's one way of also interacting with the database. So thank you so much for watching. In this lecture, we've learned how to connect to PostgreSQL database server by using different methods. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be showing you how to load a sample database into PostgreSQL. The sample database we are going to use is called the DVD rental database. This is a sample database taken from the Sakila sample database from the MySQL site. So this is the database I'm referring to. So basically I made some slight modifications to it to make things a lot easier for you. It's called a DVD rental. I've already extracted it here. So this is the extraction. This will be included in the resource page for this lecture. So you can just download it and follow along. This database should be more than enough for us to learn and practice using PostgreSQL. The database itself contains many objects. It has 15 tables, 1 trigger, 7 views, 8 functions, 1 domain. It also has 13 sequences. So once you've got the file downloaded, this file here, which is going to be available for you to download inside your resource page for this lecture. Once you've got that downloaded, what I need you to do is go to your local drive, and say your local C drive if you're on a Windows, okay, and create a temp folder. So create a folder called temp, as I've done here, and add that file to it. So on your C drive, make sure you have a folder called temp, and just add the DVD rental zipped or extracted file, the actual compressed file. Don't extract it, just make sure you add the compressed file into that temp directory. You can see 2 other files. These are not related to these lectures. These are other files that I can delete this actually because they're not related to this course. So you should only have this compressed file called DVD rental inside this temp directory, which is housed in the root of the C drive. Once you've got that done, launch the admin tool, which is I've already got it open here, which is the PG admin tool. You can launch that from the all programs, go to PostgreSQL and click on PG admin 4. So I've already got the tool selected. Make sure you've got the next thing we need to do, because we are going to load a database, we need to create a new database. So to do that, you right click on where it's got databases and go create database. So we are going to create a new database called DVD rental. So we need to give the database a name. I'm just going to call it DVD rental. I've got it all in lowercase, but it's up to you, it doesn't really matter. And the owner will be this user here called Postgres. And then in the comment, you can say whatever you want. I'll just say DVD rentals. Okay, and just click save. And by clicking save, that should install the database. So if I right click and refresh this now, this figure should change. You see it's already changed to 2, which means we have now successfully created a database called DVD rental. Now we can load the sample database. To do that, you just right click on where it says DVD rental, right click on that, and there's an option to restore. Click on restore. All right, you get this saying please configure the PostgreSQL binary path. All right, so what we need to do is configure the path for that. So click OK and click on your file option, go to preferences and look for path. This is what it's complaining about. Under path, click on binary path, and inside the binary path we need to go to where we installed the software. So we installed in program files, and there should be, click on Postgres and click inside that folder, click on the bin directory and click to get the path. So this is the path is asking for. Copy that and paste it in there and say OK. If it's happy with that, there should be no complaint. So what you need to do now, we can go back and restore the database. So click on DVD rental, click on restore, and that error should no longer occur. Okay, format, select format is going to be custom or tar. Click on that. File name, we need to select where it is, the location. These 3 dots here gives you, enables you to browse the location of where the files are. Okay, alternatively, you can manually insert the location of the file. So we're just going to go to where we've got the file stored. It's in a temp folder, this temp folder here, because sometimes it's slow. Now it's opened up. Sometimes that can be slow to open. So we click on that, the C drive, and it's inside the temp folder. It says it can't find any files. Okay, so I'm going to click cancel. Sometimes it can have problem locating the files. So I'm just going to go manually and get the location, which is in the temp folder, DVD rental, and then just cancel out of that. If you click, what you need to do is just do a slash and add DVD rental. That's it. And just get the path from there, copy and paste it in here, and that should be it. You can leave the other option blank. Role name, you don't really need that. Or you can just select Postgres, which is the user that has the privilege to install the software. So click on this restore button here, and if everything goes to plan, it tells you here restore job created, restoring backup on the server, gives you all kinds of information regarding the backup. It tells you successfully completed. So we have successfully restored the database. So we can quickly check the database. This is the database here. If you click on this schema to expand it, the tables will be located inside the schema, and the name of the schema is public. Click to expand that, and then we can see all the objects for the database. So these are the tables. These are the trigger sequences. Let's focus on the tables here. Let's expand that. We should see 15 tables. It tells you there 15 tables. So we've got all our tables loaded. So we are good to go for the rest of the course. We've got our lab sorted, and we can progress with the rest of the course. So if you've successfully loaded the database, well done. If you've got any issues, please do not hesitate to let me know. Many thanks, and bye for now. Hello and welcome to this lecture. In this lecture, we are going to look at the server service. When you install Postgres for the first time, you usually will have a corresponding Postgres server service. It is also referred to as the Postgres server. So let's open up our admin panel so we can take a look. So to open up the admin, go start and look for the Postgres server, the folder. So you see a folder here called Postgres 9.6. Click to expand and click to open the pgadmin 4, and that will launch the admin panel. This can sometimes take a while to launch, but it shouldn't take too long, hopefully. So once the pgadmin opens, we can click on the plus sign here to expand the servers. So you can see the list of servers. So just expand that. And you are prompted for a password. So this will be the password set when you install the Postgres database. So type in the password. You get prompted for this password each time. If you don't want to get prompted, you can click to save, but that is not a good practice, especially in a production live environment. But if it's a test environment like we are doing now, you can do that, but it's good to cultivate good habits, regardless if you're in a live or test environment. So click OK, and that will give you access to all the databases and objects of the Postgres. So when you install an instance of Postgres, you also have a corresponding Postgres server service, which is also the Postgres server. So you can see the list of servers here. We've got the Postgres. This is actually the Postgres server. You can install multiple Postgres servers on a physical server using different ports and also having different locations to store the data. So it is possible to install multiple Postgres servers on a physical server, provided you use different ports and also store the data in different locations. So if you want to see more, just click on this Postgres here option here, and then click on properties, and you can see a more detailed view of the server service. So it gives you some information here, tells you the name, the server type, PostgreSQL, the version, gives you the version, and it tells you the port number it's installed to. 5432 is the default, and tells you connected, true. And let's have a look. And here maintenance tells you that, username, SSL mode, give you optional prefer. So these are some information you can access from the property option when you select the Postgres option here. And the server also has some databases here. So if I expand the databases here, you can see it's got 2 here, which means there are 2 databases listed. The one is called the DVD rental, which is a sample database that we loaded on. And this Postgres database is the default database that comes when you install an instance of the Postgres relational database system. So the key thing here in this lecture is to note that the Postgres server service is also known as the Postgres server, okay, which is this one here, and that comes installed when you install an instance of the Postgres relational database system. So that is it for this lecture on the server service. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, we'll be exploring a database. A database basically is a container of other objects such as tables, views, functions, indexes, and so on. You can usually create as many databases as you want inside a Postgres server. So a database is a container of other objects, which includes objects like tables, views, functions, indexes, and other objects as well. So let's go over to our admin panel and have a look at the database and its related objects. I have already logged in to the pgadmin 4. If you are not logged in, you can log in via go to all programs and select the Postgres folder and then click to launch the pgadmin 4. Once you launch it and you try to access the database or the server, it will prompt you for a password. Just enter the password you set during the installation of the Postgres database. So the databases on this Postgres server at the moment are two. We've got this DVD rental that we loaded, and we've got the Postgres database. This comes built in when you install an instance of the Postgres server. It also installs a Postgres database. So what I'm going to do, I'm going to expand this DVD rental database so we can have a look at some of its related objects. So all these here are all related objects for a database in the Postgres server. So I'm just going to expand this here, the schema here. So within the schema, there is also the public. Let's expand that, and then we can take a look at some other related objects like a table. We've mentioned the table, so these are the tables for this database. If I expand that, you can see it says there are 15 tables for that database. And also you've got things like functions. You've got various types of functions for this. These are functions doing different things. We've also got sequences. So if if you're trying to add a record, you want them to be in sequence and so on. And then you've got views. Views are like tables, are like virtual tables. So these are all related objects of a database. So the database itself is a container of other objects, and these here, anything under this, this is the database. All these here are all container objects for the database. So that's basically what a database is. That's it for this lecture. Many thanks for watching. Bye for now. Hello and welcome to this lecture. A table is basically used to store data for a database. So any data that is stored in a database is usually stored inside a table. In a database, you can create as many tables as possible. Open up your PGAdmin4 tool. I've already logged into mine, and I'm just going to explore some of the tables inside this DVD rental database. So I've got the DVD rental database expanded, and I'm just going to expand the schema. And from within the schema, we've got the public expanded, and there is some tables here. So I'm just going to expand the tables. So these are all the tables here for the DVD rental database. And data for a database is usually stored in table. What I'm going to do, I'm going to run a very quick query so you can see how the table data is structured. So I'm going to run a quick query to see all the columns and rows for this table here called actor. So to do that, I'm just going to right click and click on query tool. And the query tool is the tool you need. It's a built-in tool that you need to interrogate data from the database. So this is a tool here. So I'm just going to write a quick statement here. Do select. So I'm now using SQL to communicate with the database. I'm just select star meaning all from the database. The table is actor, and you have to put a semicolon at the end to indicate that's the end of the statement. So what this statement is saying is that I want to retrieve all the data that has been stored in this table here called actor. So if I click on this thing here that looks like a lightning bolt, and that will execute the statement, and it will show the output in this window here. So it tells you here the total query time, tells you the time it took basically. So this is the structure. So this is how a table stores data in columns and rows. So you can see the columns here going this way, and you can see the rows here. These are all the rows going vertically and the columns going horizontally. So you can see this is all the data from this table here called actor. By using the asterisk sign, it retrieves all the data from the columns and the rows relating to that table. So this is basically how a table stores its data in columns and rows. And a database stores all its data inside tables. They have various tables, and the tables also can have some relationship between each other. So we've got a table called actor. There may be some kind of relationship via one of the columns to other tables within the same database. So that is it for this lecture on tables. Many thanks for watching, and bye for now. Hello and welcome to this lecture. What is a schema? A schema is a logical container of tables and other objects inside a database. Each Postgres database can have multiple schemas. A schema is useful in a production environment in that you can assign permissions to different IT professionals to perform various tasks within a specific schema. I have signed into the PGAdmin4, and here on the database section, we've got a database called DVD rental. And if you notice here, we've got the schema. It says here there's only one schema, and that schema, you can see the symbol here is a public schema. If I right click, we can look at the properties of that schema. It gives you the name, which is public, and tells you who owns the schema. And there's also a comment here. It tells you standard public schema, which means everyone has access to this schema. However, in a production environment, you can create several schemas, and within that schema, you can have various database objects inside that schema. For example, you can create a schema called finance and assign permissions to those who only work in the finance department. You don't really want to make that type of schema public for everyone to see because it contains sensitive information. For example, people's salaries and other financial related information. So schemas are quite important because you can use schema to group related objects and then just assign permissions to that schema. You could also have a schema, for example, for IT professionals, and as again you assign specific permissions to those who can perform tasks within that schema. Even within a schema, you can still lock things down if you wish to. You can, for example, you can create a schema called finance, and within that finance schema, you can also lock certain tables or limit the access to certain tables from people who work in that finance department. But schemas are good in that they help, they act as a logical container to hold various database related objects. So that is it for this project on schema. Just know that the schema is a logical container that holds tables and other objects inside a database, and it is possible to assign permissions to schema so you can restrict who has access to the objects inside a schema. Many thanks for watching, and bye for now. Hello and welcome to this lecture. What is a table space? A table space is basically a storage location where the actual data that is underlying the database objects can be kept. It basically provides a layer of abstraction between the physical and the logical data, and also serves to allocate storage for all relational database managed segments. We know that data in a database is actually stored in tables. In the actual tables, they are actually stored in table spaces. By default, Postgres has two table spaces. The two default table spaces provided by Postgres when the relational database management system is installed are the PG default and the PG global. So these are used. The first one, which is the PG default, is used for storing users' data, this PG default, while the PG underscore global is used for storing system data. So PG underscore default stores users related data, and PG underscore global stores system related data. So we can take a look at the default table spaces. If you log into the PG admin 4, I've already logged in, but if you're not sure how to log in, just go to Start, All Programs, click on the Postgres folder, and just click to open the PG admin 4. Once you click on the database, it will prompt you for a password. Just enter the password you set during the installation. So let's have a look at the default table spaces. So under here, you've got table spaces. You can see there it's got two, which means there are two table spaces. These come as default when you install the Postgres server. So let me expand so you can see them. So you can see the first one is called PG_default. This is used to store user related data. So any data relating to the users is stored in this table space, while the second is PG_global. This table space stores any data relating to the system. So these two come as default when you install the Postgres server. So that is it for this lecture on table space. Thanks for watching. Bye for now. Hello and welcome to this lecture. What is a view? Views are basically virtual tables that are used to basically help simplify complex queries. They can also be used as a kind of security to protect certain records from others. So views basically are treated just like a table, so you can execute or run queries on a view just as you would on a table. You can use views to hide information or protect certain parts of a table from others to see. So you can create views from a table. The sample database, which is this DVD rental, has some views. So let's take a look at them. So we're going to expand the schema here. From the schema, if I scroll down, you see we've got 7 views here for that table, for that database. So if I click to expand, you can see these are different views. For example, we've also got if I look, notice here we've got a view called actor info. Let me click to expand that. So views basically have same characteristics as a table. So you've got columns and you can also have rows. Okay, so these are all so you can query, basically you can query a view just as you would a table. So let's quickly query this view here. We've got a view here called actor info. So let me right click and select the query tool, and it should launch the query tool shortly. And when it launches, I'm just going to quickly query this view. So you query them the same way you would query a table. So I'm going to just do a simple query here. Just select star. Star means I want all the rows and columns from that view to be returned. Select star from. You always have to use from to specify where the data is coming from. So the data is coming from the name of the view is called actor underscore info, and then place a semicolon at the end of the statement. So this is the name of the view here. If I execute it by pressing this here, it should give me an output here. Okay, so basically it tells me here 200 rows retrieved from this query. So it basically behaves the same way as a table. It's basically a virtual table. So you can run queries on views just as you would a table. If I click on this table, I've got tables here. I've also got a table called actor. Okay, and you see here I've got a view here called actor underscore info. So views are virtual tables, and they're quite useful in that you can use them to simplify complex queries. Okay, and also you can use them as a security measure to hide certain records from certain people or certain parts of the organization. So that's basically what views are. Many thanks for watching. Bye for now. Hello and welcome to this lecture on functions. What are functions? Functions in Postgres are basically a block of reusable SQL code. The code can also return a scalar value of a list of records. It also can return composite objects. Let's take a look at some functions that have been created inside our sample database. We've got a sample database here called DVD rental. So if I expand the schema, we can see inside the schema there are functions. So we've got 8 functions for this database. So let me expand that, and they do different things. So they're basically SQL code that can be reused over and over again. So these are all the various types of functions created for this sample database. So you can create your own functions as well. So let's have a look at one of them here. This one here says get underscore customer balance. That's the name of the function. So to explore the function, I'm just going to right click on the properties of one of them. This one here that says get underscore customer underscore balance. And I go properties, and within the properties we can have a look at several things. So let's start with the definition. So click on this definition tab, and if I just expand this, you can see more about the function, how the function was written. So you've got the arguments for the function, the types of argument the function takes is in there, the type of value it returns, it tells you it's numeric. The language is PGSQL, and this is the actual code, okay, that generates the function or activates the function. So this is the actual code. These are basically SQL statements. So that is the definition. Let's look at the options here, what we've got in the options. All this estimated cost 100. Let's look at arguments. So you can look at different aspects of the function to see how it was created and what it does. So these are the data type. The data type is integer, which means it's a number. You've got timestamp without the time zone. You've got arguments p underscore customer ID, p underscore effective date. Let's look at the parameters. There's no parameters set. What about security? No obvious security issues here. Then look at the SQL. It tells you nothing has changed since it was created, so no modification has changed. So the SQL part of it has nothing new to explain, because nothing has changed from the when it was defined. So I can just click cancel out of it. So you can do the same with the others, just to look through to see how it has been set up. So the key thing to take away basically is that a function is a reusable block of code. If there are specific tasks that you perform repetitively over time, you can build that into a function and just execute that function to perform that task. You can also delete a function as well by dropping them. For example, if you no longer need it, just right click, and there's an option to delete or drop a function. And you can also create a function as well using this tab and using the create function tab. So there are different things you can do. You can create scripts from them. You can using the create script, or if you just want to read data, you can use the select script to extract SQL from the functions and just read data from the database. So several things you can do with a function tab. So that's basically it for this lecture on functions. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'm going to explain what a cost and operators are in Postgres. I'll start with the cost. Cost basically enables you to convert one data type into another data type. When you perform conversions using cost, it's usually done in combination with functions. So you use functions in combination with cost to perform conversions. Postgres has default cost, but you can create your own custom cost that will override the default ones created by Postgres. Operators in Postgres basically is a symbolic function. So Postgres allows you to define custom operators. Looking at our sample database, we have an option for cost. As you can see, there is none at the moment, so no cost has been created. So if we had created a cost, this is where it will be. Also functions, also the operators are a kind of symbolic function. So if you need to create or define your own custom operators, you also can do them, and they will be housed within the schema. So you've got the functions tab here. So you can create your operator, which are a kind of symbolic function. So just to wrap up for this lecture, cost basically enables you to convert one data type into another data type, while operator is basically a symbolic function. So in Postgres, it allows you to define your own custom operators. When you are using cost for conversions, you use it in combination with functions. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'm going to briefly explain what sequences are. Sequences are used to manage auto increment columns. That is, columns that have auto increments on them. This is usually identified with ID columns, columns that have to be unique. We are going to look at our sample database and see the sequences that have been created for that database. Please log into your pgadmin 4. I've already logged in, and select the option for the sample database, which is DVD rental. Click on the plus sign to expand it. And if we expand it further, go to where the schemas are, expand the schema, and we should see the sequences. This database has 13 sequences. So let me expand that to see. So these are the various sequences that have been created for this database. So let me take a look at one of them so we can see how sequences actually works. Normally when you create sequences, you can see the naming convention. You have to name it with the underscore. You have to have SEQ to indicate that it is a sequence. So let me click on this one here, the first one here, actor underscore actor ID sequence. So obviously there's a table here called actor, and that table, there's been a sequence created for that table. So I'm going to right click on this one here and select the properties. So if we go to the property, it tells you what the name of the sequence is. If we look at the definition, it tells you normally when you create a sequence, you have to set a maximum value. So here, this is the maximum value, and it tells you here this is the current value for this sequence. So for example, if I was to insert another data into this into this table, and I use the ID, it will increase it by 1. So it will now turn that into 201. So it's a column that auto increases. So if I insert a record for, say, actor ID, it will automatically change that value to 201. So let's look at the security on that. Nothing special. Look at the SQL, nothing has changed. So I'm going to cancel that, and I'm going to see if I can create a script. If you want to create a sequence, this is the syntax. You just click on create sequence, and it gives you the option. You have to name the sequence, the owner, the schema, and then you have to define the sequence. You specify the increment. How is the sequence going to increase? Is it going to increase by 1, by 2, and so on? So these are all the parameters you set when you create a sequence. So I'm going to right click and go where it's got create script. I'm just going to create the script. This is a script that would generate for you if you want to create a sequence. So let me just break it down a bit so you can see. So this is what the sequence looks. This is basically how you create a sequence. This is the SQL for it. You start with the word create sequence, and then this public here indicates the schema, which is this schema here, and this here is the name of the sequence, okay, which is actor _ actor ID sequence. The sequence will increase by 1. So if you want to insert records into a table called actor, that sequence, the ID column, will automatically increase to the next value. If, for example, the first record that you created has an ID of 1, the sequence will, when you create another record, the sequence will automatically give it an ID of 2, and so on. And this increment means it increases by 1. So if you add another record, that record will assume the next value. For example, if the record is 4, it will assume 5. The next added will be 6, and so on. Also here is, notice that it says start 200, which means that the current record for that table is 200. That means there are 200 records in that table. So if I was to add another record, it will increase by 1. That means the next record will now be 201. So there's an increment value, there's a minimum value, and this is the maximum value, which is the amount of sequences that can be created. This is the value of the, and then you have a cache. Normally you can have a sequence in cache and use that. All right, so it tells you who owns the sequence, and if you want to alter and make modifications, you can use the alter sequence command to make modifications. So this here basically is the query you use to create a sequence. So it's basically the same thing as when you write, if you do create sequence, and in the definition, all this here listed here is basically what this SQL is doing. Sequences are useful also in a live production environment. If you've got several people updating the same record or adding new records, you don't want the records to be out of sync. So by using a sequence for a column, when one adds a record, it automatically, attaches a sequence value and increases that record. So sequences are quite useful to keep records in sync. So that's it for this lecture on sequences. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be explaining briefly what the concept of extensions are in Postgres. Basically, in Postgres, extensions are used to wrap other objects into a single unit. The main purpose of extensions basically is to make it easier to maintain. So by wrapping other objects into a single unit, it's easier to maintain them. The types of